We start with this idea of something called the quadratic equation. This is an equation, so there's an equal sign in here. And we're talking about a times x squared plus b times x plus c is equal to 0. So this is the quadratic equation with coefficients a, b, and c. There's a rule that we're about to talk about here in completing the square. And there's a rule. A must be equal to 1. If A is not equal to 1, you may not complete the square. And the goal now is to convert the quadratic equation into a squared binomial. In other words, the squared binomial is going to come of the form looking like this. And we'll talk about that. This is referred to specifically as a completed square. I want you to note some things here. That if I multiply x plus 1 as a binomial squared, that I'm really talking about x plus 1 times x plus 1. Now if we just simply FOIL that, that's x times x is x squared, that's the firsts. The outers becomes plus x, the inners becomes plus x, and the last becomes 1 times 1, or 1 squared. So if we clean this up a little bit, this actually reduces down to our quadratic equation. X squared plus 2x plus 1 times 1 is 1. Let's do that again with something else. How about x minus 3 squared? Noting that x minus 3 squared is x minus 3 times x minus 3. If we FOIL that again, we get x squared minus 3x, which is the outers. The inners is 3x, and then negative 3 times negative 3 squared. Let's clean this up now, and this becomes x squared minus negative 3 plus negative 3 is negative 6x, and then negative 3 squared is positive 9. So this is plus 9. Let's go with one more example. X plus 5 squared. You start to notice the pattern here. This is x plus 5 times x plus 5. And let's talk about it this way. Isn't this the same as saying x squared plus 2 times 5x is 10x, and then 5 times 5 is 25. Are we seeing what we're getting here? What happens if we were to undo this? In other words, take that second coefficient and divide it by 2 and get 5, but then take that 5 and square it. I get 25. The things that I want you to notice here are, now I've turned this into something that can actually be factored down to x plus 5 squared. That's the completed square. So we're going to take this further now and talk about how we use completing the square. So you see, all that I need now is to say something like x squared plus 10x, except maybe this number out here is minus 7. And we're wanting to complete the square in order to make this equation into something. We can take the first two terms, x squared plus 10x, and take that second coefficient, 10, and divide it by 2 and get 5. And then take 5 and square that and get 25. I can add that 25 there and I've completed the square, but I've changed things, so I want to unchange things. I'm going to subtract 25 because that's what I added, and then say minus 7, which is part of our original expression. What we've done is we've turned this expression here into a completed square. By experience, that this can be written as x plus 5 squared. And now we combine the minus 25 and negative 7 to minus 32 is equal to 0. We could take this a little bit further if you want to. We can add 32, and this actually becomes a means by which we can solve this completed square. So I've got x plus 5 squared is equal to 32. And if I take the square root of both sides and call that plus and minus, I've got plus and minus the square root of 32. Now that happens to be 16 times 2 inside the radical, so couldn't we call that 4 root 2? And this becomes x plus 5. So when I subtract 5, I get x is equal to negative 5 plus or minus 4 root 2. And we've actually come up with two exact answers that solve for x. And that's one of the benefits of knowing how to complete the square. Let's see if we can get you to try something. How about this? X squared plus 4x plus 12 equals 0. Give it a try yourself. See if you can complete the square using the first two terms. Okay, I'm going to give my answer now in 3, 2, 1. What we're going to do is we're going to take that second coefficient, 4, and we're going to divide it by 2. And we're going to square it, and we get 4. So now we're going to rewrite things. X squared plus 4x plus 4, which is the 2 squared, minus 4, which turns that into adding 0, and then add that to 12 and get 0. We've turned this now into a perfect square, and that's x plus 2 squared plus 8 is equal to 0. That's as far as I'm going to take it. This is the completed square. We can use that to solve if we want to, and things like that. Let's do another one. X squared plus 6x minus 14 is equal to 0. Let's use completing the square. I'm going to take that second term, 6, I'm going to divide it by 2, and I get 3. And I'm going to take that 3 and I'm going to square it, and I get 9. So I rewrite this, x squared plus 6x. I'm going to add the 9, but I'm going to subtract the 9 because I'm adding 0 now, and add that to negative 14. And watch what we get. This now is a trinomial that is a completed square, so it can be rewritten as x plus 3 squared minus 23 is equal to 0, because I added negative 9 plus a negative 14 in getting negative 23. We'll stop right there. That's our completed square. Let's do one that's going to give us a negative. X squared minus 10x plus 7 is equal to 0. All right, take that second coefficient, divide it by 2, square that, and add it. But subtract it because we're going to unchange what we just changed. So this now is our completed square, and there we have a completed square expression.